Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by AWS and Nirmata. My name is Cody, and welcome back to Tech Strong Learning. We've got an exciting panel ahead, but before we get things started, I do have just a couple of housekeeping notes I'd like to review with you. First of all, we are recording today's session. So if you miss any of our discussion, if you'd like to rewatch at a later point in time, or of course, if you'd like to share with your team, you will be receiving the on-demand recording via email shortly after we conclude this live session today. If you'd like to engage with us, there are a couple of ways to do so. The first and the easiest way is located on the right side of your screen, and that's going to be the chat tab. If you see that chat tab, let us know from where in the world you are joining us, because I know we have a global audience and some global presenters as well. If you have any questions, we do want you to send those in to the Q&A tab. You can find that Q&A tab on the right side of the chat panel, and sending in your questions will just help us keep organized and help us ensure that we can address as many questions as possible today. Additionally, we do have 2 polls that will be running throughout today's program, so keep an eye out for when those pop up on your screen. And before we close things out, I am giving away 2 $25 Amazon gift cards, so be sure to stick around until the very end to see if you're one of our lucky winners. So enough of that. Let's dive straight into our topic of securing cloud-native workloads, a deep dive into achieving zero trust through effective policies on AWS. And I'm joined today by our moderator, Randy Bells, Strategic Partner Development Manager at Nirmata. And Randy, I'm going to kick the floor on over to you to open up the panel and introduce the rest of us.
Awesome. Thank you for that. Hi, everyone. Thank you all for joining our webinar today. We are super excited. My name is Randy Belts. Once again, I will be your moderator. We do have 3 speakers for today's webinar, and I will go ahead and let them introduce themselves.
Good morning, all. My name is Radna Chittal. I work at TIA and manage cloud security as well as DevSecOps teams. I've been working on AWS since 2007 and have been working on Kiberneo for the last several years as well. I'm looking forward to this fun discussion today. Thank you.
I'll go next then. Hi, everyone. My name is Riccardo Freschi. I am a senior solution architect working at AWS in the partner core team. So I work predominantly with partners, and I specialize in application modernization. Welcome, everyone, and thanks for having me.
Hey, everyone. Thanks for joining. This is Jim Bagwadia, co-founder and CEO at Nirmata. I also work in the CNCF community as a maintainer of Kiberneo, which is a policy engine for Kubernetes and cloud-native systems, as well as a co-chair in the policy working group. Thanks for joining and looking forward to the discussion.
Thanks, speakers. I appreciate it. We're super excited to hear about your thoughts on zero trust. To start us off, we're going to go ahead and do our first poll question. If we could go ahead and launch that. The question is your organization adopting the zero trust approach to security? Yes, no, and unsure. And we'll give everybody about 30 seconds. Awesome. We'll go ahead and continue on. Can we launch the results from the poll question number 1? I think our poll question is all over the place, so we'll go ahead and jump into our topic. This is, once again, a panel session for a topic that is top of mind. So let's go ahead and hear from our speakers, their thoughts about zero trust. The first question, Ricardo, this is for you. Can you provide a brief overview of the zero trust security model and explain why it's relevant in today's cloud native landscapes, particularly on AWS?
Sure. Thanks, Randy. Please, maybe first allow me a small preamble. Let me talk about security at AWS. So security is AWS top priority. So AWS has been architected from the ground up to the most flexible and secure cloud computing environment. AWS, the infrastructure, is built to satisfy the requirements of high sensitivity organizations, like, for example, military and global banks. So the supply chain that goes into our security services and security services specifically is vetted and accepted as secure for top security workloads. And this benefits not only those organizations, but also all our customers globally. This is supported by a large number of tools that we have at AWS. It's over 300 over security, compliance, and governance services. We also have 98 security standards and the compliance certifications. With our customers, we have a shared responsibility model. What that means is that AWS manages the controls of all the components from the host operating system and the virtualization layer down to basically all the physical security of facilities, also known as data centers. And our customers take care of the security of their applications. In order to help them with achieving the best security standards, we provide, of course, a lot of best practices document, tools, services, and various types of guidance. So now you asked about the zero trust model. So let's talk about that now. Organizations traditionally have been relying on the common practice of perimeter defenses to protect themselves from malicious entities. So the problem is that offenders find new and innovative ways to overcome the perimeter, and so place the first foothold within the perimeter. And that basically leads to the possibility of carrying on attacks deeper into the network from within the perimeter. So the security of the perimeter itself is not enough. We must treat cloud native clients, the services instances, the services request, and the data and the network as untrusted. So zero trust considers any client as a suspect. That may be, itself used to commence attacks. So, for example, a client might be authenticated and authorized, but it might be that the client itself has been compromised. So, zero trust considers also the internal network as hostile for the same reasons, exactly like the external network. It takes into account that, like I said, the possibility that good citizens that are within the organization network, being them like actual physical human being logged into our systems, or services themselves can be already hacked. So, and become here a stepping stone for offenders to take further attacks. Zero trust requires that users and systems prove that their identities and that they are trustworthiness. So let me give you a little bit of an example of zero trust principles at work within AWS. So AWS, like we probably know all, is based on APIs. Every day, our customers interact with AWS, making billions of API calls over different networks. So each one of these API requests is individually authenticated and authorized every time. There are, to give you more sense of what I'm talking about, there are hundreds of millions of requests per second. So to secure our communication, AWS uses TLS, so network level encryption, together with cryptography of a signature v4. That secures the request without any regard to who is requesting and where it is the requester is placed. So regardless if it is within what the secure perimeter is considered or not. So you can achieve the same level of security thanks to SIG-v4 on products like the Amazon API Gateway, which is a service that allows software interfaces to securely be available externally. Just to give you a few more details, API Gateways features DDoS protection, ray limiting, and supports IAM. Supporting IAM and together with SIG-v4, SIG-v4, it can allow you and all customers to actually enforce strong authentication and authorization from the gateway of your environment. That's it. I hope it answered the question.
Awesome. Thanks, Ricardo. I appreciate the insight. To kind of piggyback off of that, what do you think are some of the specific challenges that organizations are facing when it comes to securing cloud native workloads on AWS? And why do you think the traditional security model is falling short?
Right. So traditional security models fall short because of the underlying assumption that location means safety, like mentioned earlier. So what we see is that the two biggest cloud security risks continue to be misconfigurations and vulnerabilities. Which are basically introduced through the software supply chain. That is on top of all what we discussed earlier. So, for example, according to a recent report, 87% of container images running in production today have critical or high severity vulnerabilities. So, organizations need to adopt increasingly a shift left approach. So try to insert security upstream in the development and deployment processes on top of the runtime security approaches that we discussed earlier. So to mitigate these issues, these security issues, and to enforce zero trust, AWS provides a number of services and tools. So, for example, let me mention a couple of them. AWS Security Hub, which is a more generic tool, and more specifically, for example, to Kubernetes and containers, GuardDuty EKS runtime monitoring. So Security Hub is basically a tool that provides users, organizations with a comprehensive view of the security state of your organizations and account in AWS. So it basically enforces that, allows that through both AWS services and through partner third-party products. So how it does that is it does that through rules and security check controls that are associated to standards. For example, a rule can be a security group should not allow ingress from the open world to some port, let's say 22. Security Hub puts together this list of rules into a standard and checks that these rules are actually there and continuously monitors your security posture. Guard Duty, EKS runtime monitoring, that is fresh announced at the end of March this year, and provides continuously updated threat intelligence feeds. They are processed and they are checked against, for example, list of malicious IP addresses, CIDR ranges, and uses machine learning to identify any potentially unauthorized activity from malicious entities. For example, to speak more concretely, one of these types of potential malicious attacks could be the noted and detected and highlighted, for example, because of escalation of privileges in a container. That's it.
Awesome. Thanks, Ricardo. I appreciate that. We're going to go on to our third question. Policies are often cited as foundational element of zero trust. Could you elaborate on how organizations can effectively define, enforce, and adapt policies in a cloud-native environment? Jim, we'll start with you on this one.
Thank you, Randy. So yeah, policy tends to be a fairly general term, right? So let me take a little bit of time to explain what we really mean by policy over here. So obviously in real life, all of us work for organizations, companies where we have things like vacation policies, other, organizational policies. And it's really a set of guidelines which we all use to, kind of manage how we are acting, behaving, interacting with each other. In our digital world, with systems like AWS and with cloud native systems, policies translate to digital policies, which can be enforced, of course, at various levels of the system, and can be audited and checked, like Ricardo was discussing with rules in AWS Security Hub, or if you are using policy engines from CNCF like Kyverno and others with specific checks in there. So again, tying that back into a standard, like let's say for zero trust, as an organization, you might decide, and which is a very good practice, to say all data must be encrypted. But at a very high level, that is just, a very generic policy or guideline that the organization can put in place. But then you have to translate it down into every system where, for example, if you're using AWS S3, you want to make sure your S3 buckets are encrypted. If you're using, Kubernetes clusters with EKS, you want to make sure that anytime a pod requests a volume, that volume, if it's an EBS volume, it's also encrypted. So with policy as code and with digital policies, now you can, check each one of these controls. Like Ricardo was mentioning, in our cloud native world, everything goes through declarative configurations and APIs. So we have the potential of checking each one of these, auditing. With systems like Kubernetes, this can be done at admission controls, can also be done at runtime. And of course, if you're using, infrastructure as code, you can also put this into your CI/CD pipelines. So policies become that digital contract or that digital building block on which you can layer the principles of zero trust and other security best practices.
Awesome. Thanks, Jim. Aradna, are you seeing the same thing? What are your thoughts on this topic?
Definitely, Randy. Thank you. In an enterprise, in addition to deploying, zero trust principles on security, defense, and depth, I think there are other key considerations like velocity of deployments, developer experience, and every organization has some kind of standards, compliance requirements, or privacy requirements at a high level, and they can be translated into policies as well. But imagine a developer trying to learn all these compliance, regulatory, as well as security policies. It's just practically impossible, and to keep up with the threat landscape in the industry. So, the best way to implement these policies for an enterprise is to shift left, as Ricardo and Jim both have said, in a CI/CD pipeline. So, upfront during the development, distribution, deployment phases, the developers have a paved path. The policies are already identified and they are being enforced through admission controls. And developers don't have to worry about codifying all these policies, because as they start to develop and deploy software, it is automatically enforced, and they are given guidance that here you are violating this policy, you need to go fix this or change this configuration or this manifest. So that provides a paved path, improved developer experience. At the same time, enterprises can use zero trust policies and strengthen the security posture in the development, distribution, deployment, as well as in the runtime phases.
Awesome. Thank you, Ron. I appreciate it. To kind of go into our next question, can you kind of share some of real world use cases or examples of how zero trust policies have been applied successfully to microservices, containers, and serverless on AWS?
Definitely. As I mentioned in my previous answer, that policies apply to development stages, distribution of the software, deployment, as well as runtime. In development, obviously, we want to validate any software supply chain threats, right? If there's a validate the SBOM, if there's any malicious component as part of the application build, then you should be able to block it in the development stage itself, and not allow the application to move forward. At the same time, in the distribute phase, also, there are multiple ways you can distribute these policies, right? Control planes communicate constantly the policies to the data plane. And then network policies and zero trust policies like blocking designated ports and protocols, ingress rules, malicious host names. You can define all those policies and block them during the deployment stage, or during the deployment stage and distribution stage as well. And then, in addition to that, validating the artifacts, right? The manifest, declarative state of the Kubernetes clusters, pod security policies, validation of tags and labels in the pipeline, whether you're tagging and labeling appropriate resources according to the policies, and then deployment of these manifests, right? Istio manifest as well as Kubernetes manifest to validate the configurations and secure configurations as per the policies that have been defined. Network connectivity rules, which workloads are allowed to talk to which other workloads, and who has access to what resources. Access control policies and network access control policies is a huge part of the policy definition and as part of the development as well as deployment pipelines. Um, and then runtime, right? Once you have deployed it, validating image programs, whether what you have in the repositories is what is actually running in production. Patches and vulnerabilities, any detection of violation of policies that we had validated in the development stage, and then escalation of privileges, or containers running with enhanced or privileges, or like root. And then adherence to certain benchmarks like CS benchmarks and runtime vulnerability detection. These can all be policies for auditability as well as accountability that can be enforced at different stages of the pipeline in development, deployment, distribution, as well as runtime.
Awesome. Thanks, Aradhana. Jim, are you seeing some of the same use cases, or can you give us any example?
Yeah, absolutely. Right. So, like Aradna described, as you're looking at applications, workloads, certainly taking that, view of a layered system and going through each layer, making sure that any potential attack vectors or potential risks are mitigated through policies, through checks, makes sense, right? So, in the example of cloud native workloads, you typically start with your infrastructure. So, on AWS, there's several different infrastructure services. If you're using infrastructure as code, and let's say you're spinning up, your infrastructure based on requests from your development teams, etc. Policies first, of course, can apply there. But then as clusters come up, clusters introduce another layer of, a form of virtualization and again, autonomy on top of this infrastructure, right? So for the clusters itself, things like CIS benchmarks can be translated into policy checks. That needs to be, enforced. And then within the clusters, you have containers running, application containers, which are delivered by different development teams. Typically, clusters tend to be shared within organizations. You could have clusters per team or maybe even per app, but then, of course, some of the power and flexibility of Kubernetes is in sharing clusters across these, type of heterogeneous workloads. So there, that introduces yet another layer of complexity where if you are sharing a system, how do you make sure that every application has sort of this trust boundary and cannot impact other applications on that same system? So this is where things like Aradhana mentioned, network policies. If you're using service meshes like Istio or others, you would apply policies at that level. So that comes into play. And automating some of these configurations, for example, policy engines can help with every time a new namespace is created for a new workload within a cluster, automating not just things like role based access control for that namespace, but automating network policies, right? So that becomes critical because the whole idea, the whole principle of cloud native is to move towards self service, empower developers. But you can only do that through proper automations, and that cannot be, like Aruna was mentioning, paved paths with platform engineering teams typically put in place for their development teams. So, as part of that, you want guardrails to check and you want the proper automation to make sure that as the system evolves and changes, security controls are automatically configured and not left to some manual afterthought.
Awesome. Thanks, Jim. I appreciate it. We're going to go into our fifth question, and this is directed towards you, Aradhana. As cloud native environments are dynamic and evolving, how can organizations ensure continuous compliance with zero trust principles? And what role do adaptive policies play in strengthening security posture?
Thank you. Interesting question. So traditional security model when enterprises were in data centers, was hard exterior, soft interior, anything can talk to anything. But the very fact that zero trust principles or zero trust model has gotten so much adoption lately, this is not a new concept. It's been there since 2001, right? When BeyondCorp came up with their zero trust model the first time. It wasn't called zero trust, it was called microsegmentation, deperimeterization. But as enterprises move their workloads to cloud native technologies, we are in a continually distributed world. At the same time, we are distributed and connected. Everything is connected to everything. So as you move from on-prem to cloud native, the context is continually changing for the applications and services that you're providing. As the context changes from on-prem to cloud or one cloud to another, or from one VPC to another, or one cluster to another, or one application to another, the controls and decisions made for security controls are dynamic, right? The context is changing and the decisions have to be dynamic as well. And the access decisions have to be made dynamically based on the identity of the user, the identity of the application, at the same time, and the device as well. So hence comes the need for adaptive policies. The very principle of zero trust means continually, iteratively improve the security posture. It's a continuum. You can't be zero trust tomorrow. It's not a switch that you can flip, right? It is a principle and a philosophy where you're continually evolving your security model based on the threat landscape, because threat landscape is so dynamic and it changes very quickly and workloads are very ephemeral. So hence the need for adaptive policies. So as you see the threats changing and the context being dynamic, automatically your policies are adapting to that new context and defining controls for your workloads to be deployed in the ephemeral world
Awesome.
that we live in today. Thanks.
Thanks, Aradhana. I appreciate it. We're going to go into our sixth question of the day. Tooling and automation are crucial in managing policies in dynamic cloud native environments. Jim, can you kind of discuss some recommended tools and strategies for streamlining policy distribution, reporting, and management?
Yeah, certainly. So when it comes to, you know, managing any system, of course, there's the tooling side of it, but there's also the human side of it, right? And if you kind of think about, just the evolution in our, industry itself, we've, evolved from system administrators where you would have a very, sharp handoff between developers and operations teams. In the early days of course, application development, an application developer would almost never be allowed to touch production systems, right? Now, of course, that has become with DevOps and with the, sort of more of a collaborative approach. Developers do have to get involved in production systems. They do have to, at least at the application layer, have that visibility, as well as the ability to troubleshoot, manage their own applications. And the operations teams are providing more and more tooling which enables that self-service. And then that evolved more into DevSec and Ops, where people were saying, well, what about security? How do we bake that in and make sure both developers and operators are thinking about security as part of this? And today, in the cloud native community, that has further evolved into what's now known as platform engineering, where these DevSecOps teams are taking on the responsibility of building internal platforms using tools like Kubernetes, platforms like AWS and other services, and providing, secure self-service interfaces to their internal application delivery, application management teams. So going back to, policy management, if you think about it's not just about defining a set of policies and putting them into place. It's about also being able to make sure that all of these roles, developers, operators, security teams, have visibility into these policies at all aspects of the system. It doesn't help the organization if your policies are stuck in some proprietary tool and nobody can access it, nobody can see that you need a license to be able to get to that policy definition, right? Or similarly, if your policy reports are not easily available to the right people at the right time, again, developers, operators, security teams, how does everybody see the reports in the systems of engagement that they use, instead of this being in an island in a separate security tool? And also, if a developer, let's say, needs a policy exception, how do they, kind of manage that workflow, request an exception? How does the security team authorize that, provide that? So these are all human interactions which need to happen using digital systems of engagement, right? So translating it back into policy management and where we are in the community, the very interesting thing that Kubernetes provides. Kubernetes is not just about managing containerized workloads. It is an extensible architecture which allows you to extend its API sets into allowing things like policy reporting, policy exception management, even policy declaration. So now this becomes a common layer, a standard set of tools which everybody in the organization can use. It's open, it's composable, and you can have different systems pulling and interacting with this data. Like if you're using Git and GitOps, you can have that information, flow from your Git pipelines into Kubernetes. You can also, of course, scan for these type of configurations, as well as the security rules that you want, and you could report them directly in your pipeline. So now, again, all three roles are seeing not just policies, but they're starting to see the policy reports, they're starting to see exceptions and manage all of this. So when we look at policy management, standardizing on a set of, APIs, systems, and making sure that they're widely available across, your organizational roles is extremely crucial.
Awesome. Thanks, Jim, for the insight. I appreciate that. Our next question, Aradna, I know you kind of touched on this earlier about how zero trust often requires a cultural shift within organizations, but can you provide some insights into how organizations can foster a zero trust mindset and encourage collaboration between platform engineers, security experts, and DevOps professionals?
Definitely, Randy. As I said, zero trust is a philosophy that requires continuous iterative improvements in the cybersecurity posture based on continuous monitoring, evolving threat landscape, and security policies that continually adapt to the risk that is posed by the changing threat landscape and the ephemeral nature of cloud and cloud native technologies. The culture change takes a bit of a time. It's again a continuum, and you continually improve the knowledge transfer to the developers as well as the platform engineering teams. But at the same time, um, it's important that zero trust principles are being enforced iteratively and continually through the platform security as well as the CI/CD pipelines. Like I said, that if you build security into the platform and you have adaptive controls, and then the CI/CD pipeline, you provide paved paths where a developer is actually guided through the development and deployment and distribution as well as in the runtime as to what the security threats are, what are the policies that they are breaking by implementing a particular manifest or a particular piece of code. I think that makes developers knowledgeable over time and they learn as they go. And that leads to a culture change, right? At the same time, like I said, no one person can keep track of all the threats in the industry, right? So having that adaptive policy framework in the organization implemented through DevSecOps and collaboration between the SRE teams as well as platform engineering teams as well as the CI/CD pipeline to chain, I think can really help in evolving to a zero trust model for an enterprise as well as continually improving the knowledge and changing the culture of the organization as well. Hope that helps.
Awesome. So after that cultural shift, what do you think are some key considerations for decision makers and executives when adopting AWS for cloud native technologies in terms of implementing robust zero trust security measures?
So Ricardo gave a lot of details on that in this first question, right? AWS platform and services provide many tenants which can be utilized to build a zero trust architecture easily. For example, platforms like EKS, they provide controls. Again, it's a shared responsibility model. They provide services, but the tenant has to actually secure all those configurations for themselves. Controls around control plane, data plane, security control policies at the global account level, and then resource level access policies based on criticality of the resource. And then all the tool chain that they provide for building a pipeline, ECR, etc., right? Tools and technologies that they provide. And then at the same time, fine grained authorization for resources in collaboration with access control and access policies. From a management perspective, obviously, key consideration for adoption of any technology is out of the box features. I mean, the whole point of going to cloud is that we are not reinventing the wheel, right? We are using the services that are provided by a service provider. And then the developer experience, right? The more customization we have to do, the more changes we have to make to a platform that makes it harder to adopt. And then defense and depth mechanisms that are available for securing workloads. AWS has come a long way since it provided first EKS service, right? They've evolved, they've provided a number of other security features that enterprises can leverage for, and they can be easily integrated into your pipelines as well as the platforms. And also integration with third-party platforms and services, because no enterprise is just in cloud, right? Very few organizations are 100% in cloud. Most of the traditional enterprises are hybrid. So they have on-prem tools and then technologies in cloud and cloud native platforms. How do you use existing tools and integrate them to have an end-to-end view for an enterprise? I think that is another key consideration in a hybrid platform, tools and their integration. Um, I think those are some of the high-level key considerations for using AWS for containerized workloads and zero trust.
Thanks for the insight, Aradna. I appreciate it. So our next question is going to be directed at all of our speakers. So Jim, we're going to start with you on this one. Can you share any recent trends or innovations in cloud native security, especially related to zero trust and policy driven approaches that webinar attendees should be maybe aware of?
Yeah, so certainly, as Aradhana was also mentioning, that the space keeps evolving and cloud native evolves at a rapid pace, right? So, but there are a few constant themes which have emerged, which are extremely useful to all organizations, right? The first one trend with cloud native, which is very dominant, is to codify as much as possible, right? So, and what we mean by we hear about terms like infrastructure as code or policy as code. So, what does that really mean, right? And why does it matter? So, with those type of best practices or with that type of guideline, what we're really talking about is applying software engineering, software development practices to these declarative API driven systems. And what that means is you're using version control systems like Git. You are using automation, you're using code reviews, you're using even testing before things get into your actual production system. So testing could be applying again policies and rules in your CI pipelines to check for things, verify at every level, but keeping in line with the zero trust principles. So really the first aspect of this is to codify as much as possible, adopt policy as code, adopt infrastructure as code, those type of principles. But then automation is the very next step, right? So once you have made these declarative artifacts that your teams can collaborate on, you want to automate. Which means that once something gets pushed into these type of systems, like again going back to an example, if you're using Git for this, the pipeline itself will trigger the deployment into production. If a team wants to request a namespace on a cluster, even that could be again approached in the same manner, where they're requesting that in a Git system, which becomes your system of record for audit trails, as well as approvals, things like that. That triggers automation, which then kind of responds to that after the right policy checks have been enforced to interact with the runtime systems. And then finally, it's the collaboration, right? Because without that bringing together the development teams, the security teams, and the operations teams, this is not a problem that any one team can solve by themselves, right? That collaboration must exist, and using these digital, artifacts again makes a lot of sense. So yeah, to codify, to automate, and then to collaborate, I think is the cloud native way.
Awesome. Thanks, Jim. Aradhana, do you have any recent trends or innovations you would like to add in or have any thoughts about?
Personally, I'm quite excited about AI and Gen AI and potential to use Gen AI for cybersecurity. As you see, that can drastically help achieving or shortening the path of achieving zero trust. Because imagine from adaptive policies, we go to predictive policies, where you are getting ahead of the curve and you're predicting what policies should be enforced on a particular workload based on the context of the workload. And then continuous monitoring and behavioral analytics, AI can add a huge component there that provides intelligence into the policies. And the whole cloud native security posture can be taken to a different level using AI and Gen AI. I know there's much to be explored in this area. We've just started some conversations in our CNCF tax security working group. But that is what I'm excited about. And I think that will definitely help us take security to the next level.
Awesome. Thanks. Ricardo, from the AWS perspective, are you seeing any trends or innovations or something to look forward to in the future?
Sure. Let me mention two services from AWS. One is fresh from the end of last August, which is the support of Kubernetes network policies from AWS VPC CNI. So we talked about policies a lot. Specifically, this is about Kubernetes network policies. So out of the box, well, every pod can interconnect and talk to each other. But with the network policies, you can put in place basically virtual firewall rules that define ingress and egress for pods, so that you can basically define based on various criterias like the labels, the namespaces, CIDR ranges, ports, and so on. You can define what pod can communicate with what other pod. So up to, well, recently, that was not supported by the VPC CNI, and now it is since August. So yes, so you can define your network policies, and they are supported by the VPC CNI. The other one I wanted to mention is EKS audit log monitoring. So I talked about the guard duty EKS runtime monitoring earlier. And so let me also mention that the audit log monitoring helps you detect the potentially suspicious activities in your EKS clusters. And basically, when you enable the audit log monitoring, guard duty immediately begins to monitor the Kubernetes audit logs. So what they basically are about is the logs which are listing all the activities from users, applications, and the Kubernetes using the Kubernetes API. So thanks to this functionality, guard duty starts and keeps monitoring the logs, these kind of logs. So this is specifically very useful in a combination with the runtime monitoring, because used together, they can leverage more context. So, for example, a runtime-based detection. So the runtime monitoring detects something, let's say on a pod, that is exhibiting some suspicious behavior. Then that detection can be augmented in context by the information captured in the audit log. So, for example, indicating that the pod was unusually launched with elevated privileges. So hopefully that answers the question.
Great. Thanks, Ricardo. That's going to bring us into our last question of the day, which I would like everybody on the panel to get a turn on. So we'll go right into it. So in the context of the constantly evolving threat landscape, how can organizations stay proactive in adapting their zero trust policies and security measures to address emerging threats and vulnerabilities? Aradhana, we'll start with you on this one.
Sure, Randy. In my opinion, it's really important for organizations to measure the success with zero trust. What doesn't get measured doesn't get addressed, in my opinion. And it's there are frameworks out there to assess your controls against zero trust maturity model and figure out where you stand. And based on that, you identify deltas and continually improve them wherever you have gaps. You could have gaps in continuous monitoring. You could have gaps in your policies. You could have gaps in your CI/CD pipelines that you need to plug in to strengthen your security posture and ultimate zero trust in the runtime, right? And the very fact the platforms that are CI/CD pipeline tools, etc., are also hosted on a platform, making sure there are no backdoors into the CI/CD pipelines, and continually looking at the threat landscape. And because that is going to evolve, and based on that, you continually update your policies, getting right kind of threat intel on cloud and cloud native technologies is important. I mean, there are all kinds of threat intel feeds that you can subscribe to, but the specific ones for cloud and cloud native technologies is important to build and strengthen the policies that are relevant to your deployments in AWS or in any hybrid platform or multi-cloud platforms as well.
Great. Thanks, Aradhana. So, Ricardo, from an AWS perspective, how are you supporting your customers to be proactive in adapting this zero trust?
Yeah, yeah. So, well, what our suggestion and our recommendation is to start evaluating your workload portfolio and determine where you can get the best advantages from zero trust approach. So where you can get the greatest benefits. Um, so so that practically means that you need to look at mainly two tenets, which are assume breach, assume that there is a breach, there can be a breach, and there will probably be, and never trust. So assume a breach because, like we discussed earlier, every image, container image can contain vulnerabilities. That every service is vulnerable, every service can be exploited at some time, and that a cluster network can be hostile. So the other tenet that I mentioned is never trust, which translates into three views. So one, authenticate both the server and the client. Continually monitor, so try to monitor continuously the what's going on within the network. So like I said, the service, the client, the service request as well, and the continuous behavior of all the actors. And maybe try to attach some tag the entities with some confidence level about their security. And of course, apply the principle of least privilege. Again, it's always identify, so authentication, and authorization, of course, always analyze, so keep monitoring, and finally, always control. So at AWS, for example, to get you started, we have the well-architected framework. It has 7 pillars, and one of them is specifically security. We have a white paper on that, specifically on the security pillar, and countless articles and blogs. So more concretely, what you can do, what the development and platform teams can do, well, for example, could be monitor, again, the behavior. So don't rely just on a single authorization once because it was authenticated, maybe a request was authenticated at the beginning. Try to have security in depth. At every layer, try to put in place the right level of security. Encrypt, like mentioned other times, your data in transit and at rest. Maybe eliminate unnecessary pathways. So every entity, like we said, is to be considered a potential threat. So cut away possible unnecessary further steps. And when you can, leverage gateways to manage the communication between entities. That's the answer.
Thanks, Ricardo. Jim, do you have anything to add in terms of?
Yes, certainly. One thing to add here is that, like we've talked about, and we've mentioned several tools, technologies. So there's no lack of tooling out there to help secure systems, right? And that, I believe, is not the challenge that organizations face. And it's also, the realization that no one tool is magically going to solve everything, right? The real challenge, even with all of this tooling, if you look at every survey out there on security, the majority of security incidents tend to be because of misconfigurations, like Ricardo earlier pointed out, or because there's not continuous like scanning and checking in place in the right levels of the system. So how do we address that problem itself, which is the fundamental root here? And really, the thing I would point out is you need to make sure within an organization that the teams responsible for systems are empowered to collaborate and manage and really buy into whatever policies, guardrails, etc. you're adopting. So if only a few people within your organization can understand, read, write, manage policies, that's not going to work. You're going to end up with more misconfigurations, more or systems which are neglected. That doesn't help with any of the shift left type of approaches that we all want to get to. So to get those teams to buy in, you need to kind of be adopting tools, technologies which they are familiar with and really speak in their language, right? So that's where within the cloud native ecosystem, solutions like whether it's Kyverno or Open Policy Agent, they work very hard to enable those domain experts to be able to write, manage, and automate policies at scale. So certainly that would be, I think, that my biggest suggestion is to kind of think from that perspective and really empower the domain experts and the platform engineering teams to be able to scale these type of solutions.
Awesome. Thank you, speakers. I appreciate all of your insight. We're going to go ahead and go into our second poll question of the day. So we'll go ahead and launch that. Are you using policy-based security to project your cloud native workloads? And yes, no, unsure. And we'll give everybody about 30 seconds. Okay, I think that gave everybody the correct amount of time to answer. Since we only have about 3 minutes left, I believe we only have probably time for one more question. If you could put it in the Q&A section, we'll be happy to answer it. We'll give everybody about 20 more seconds to do so we can wrap up. Ricardo, I do have a question for you. So you've talked about container images and vulnerabilities. Are there any services that AWS provides to help with mitigating those?
Yeah, sure. Thanks for the question. So Amazon ECR static image scanning. That is basically a service that integrates with Amazon Inspector, and it provides continuous scanning of your ECR repositories for basically your images uploaded to ECR. So it scans both the operating system and the library, programming languages, and these kind of vulnerabilities. Yeah, so that is it. And basically, when there are these kind of detections, it can send you also a notification on the event bridge, so you get it as soon as they are detected.
Awesome. Thanks, Ricardo. I know we're coming up on time, but I want to thank all of our speakers for sharing your knowledge. I know we all appreciate your perspective on Zero Trust. And a special thank you to all our audience members. As a reminder, the webinar recording will be sent out. And if you would like to connect with any of us on LinkedIn, feel free. And thanks for joining us, and have a great rest of your day, everybody. Thank you.
Thanks. Bye-bye.
Bye.
Thank you.
Awesome. Well, thank you, Randy, and thank you to the rest of our panel today. Like Randy said, we did record this. You will be receiving an email with a link to access that recording, or you can find it on the Cloud Native Now website. Just visit cloudnativenow.com/webinars. The two winners of our $25 Amazon gift card drawing are Carlos G. and Chandra D. So to our winners, congratulations. Keep an eye on your email for an email from myself. I'll be contacting you shortly to distribute your gift cards. If you don't happen to see an email, check your spam folder just in case it happened to be filtered out. I'd like to thank AWS and Nirmata for sponsoring our program. And to everyone hearing my voice, thank you so much for being here until the very end. There is a link at the top of the chat for our post-webinar survey. We'd love to hear your thoughts, whether they're about today's program or suggestions for future topics. Let us know. Either way, we hope to see everyone at a future TechStrong learning experience. Have a great rest of your day, and you may now disconnect. Thank you again to Aradhana, Jim, Ricardo, and Randy.
Thank you.
Thanks, everyone.
Have a good day.